Begin the study of this algebra course with a description on relations and functions. What does relation means? In algebra, we deal with variables. So obviously, we are talking about relation between variables. Now, a relation, what does a relation actually do? A relation establishes a connection between two or more variables. Well, we are used to hearing of variables like x, y, and so on. So if we can establish a relation between two variables, that is the kind of relation we are talking about. For example, let's think about a student working and earning $7.50 an hour. A student assistant on work study earns $7.50 an hour. Now, the amount of money the student makes is actually related to the number of hours that student works. And I have made a table here for you. Look at this. When a student works for 1 hour, the student takes home $7.50. A student working for 2 hours takes home an amount of money, $15. Now, look at the relation between two variables. What are the two variables here? The variables are the number of hours that we call T and the amount of money that we call A. Now, can you write a mathematical relation between these two? How are these two variables related? When T equal to 1 hour, A equal to $7.5. When T equal to 4 hours, A equal to $30. And so, we can write a relation between A and T. Well, you can tell me what a relation is. How is T related to A? We can say A equal to 7.5T. Is that right? When T equal to 1, A equal to 7.5. When T equal to 2, A equal to 15, and so on. So here, this is a relation that establishes that connection between the variables A and T. Now, here we call T as the input and A as the output. Is that right? You input T equal to 1 hour. You work for 1 hour. You output A equal to $7.5. You take home $7.5. All right. Now, we will represent that as an ordered pair. Well, you understand all these. An ordered pair, 1, 7.5. Remember, the first value of the ordered pair is the input, and the second value is the output. So what does an ordered pair do? An ordered pair gives you a relation between the two variables that we call input and output. When you work for 5 hours, the input is 5 hours. The output is $37.50. And the corresponding ordered pair is 5, 37.5. Now, if you look at this relation, A equal to 7.5T, each input gives you a unique output. In other words, no value of input gives you more than one output, does it? You work for 1 hour, you take home only $7.5. You cannot take any other amount of money. So one input gives you only one output. That means if you draw a graph of this, it will be a straight line. Is that right? It will look like this. And what does the slope of this line represent? You see, A equal to 7.5T is a linear equation, a linear relation between T and A, and the graph of that is a straight line like this, and the slope of that will be $7.5 per hour. On the other hand, let's now consider the relation y squared equal to x. Y squared equal to x. An input of x equal to 4 can produce an output of y equal to -2 or +2. Is that right? How? Because -2 squared will give you 4, +2 squared will also give you 4. So a single output x equal to 4 will actually produce two values. A single input x equal to 4 will actually produce two values of the output, y equal to -2 or +2, because -2 all squared equal to 4 and +2 squared also equal to 4. Now let's get some ordered pair for this relation. Now we already have a pair of ordered pair there. What are they? When x equal to 4, y equal to -2, x equal to 4, y also equal to -2. In other words, 4, 2 and 4, -2 are ordered pairs of this relation. Is that right? An input of x equal to 4 gives you an output of 2, also an output of -2. Let's mark those ordered pairs. This is x equal to 4, y equal to 2. And the second ordered pair is 4, -2. There you are. Now, also, an input of 1 will give you an output of 1 or -1. Is that right? Because -1 squared equal to 1. Also, +1 squared equal to 1. That means 1, 1 and 1, -1 are both ordered pairs for this relation. Let's plot those points. That's 1, 1 and that's 1, -1. How about another ordered pair? If the input is 9, what are the possible values of the output? You see, 9 can be produced by squaring either 3 or -3. 3 squared equal to 9, -3 squared also equal to 9. That means 9, 3 and 9, -3 are another pair of ordered pair for this relation. Let's mark those points. That is 9, 3 and you have -9, 3. And how does the graph of this relation look like? Look at that. That is the graph of that relation. All right. Now, looking at the graph, you know that for every input, this relation gives you two outputs. Now, the graph of such a relation has the part above the x-axis, which represents the positive outputs, and a part below the x-axis, which represents negative output. Now, if you draw a vertical line, look at that vertical line. It cuts the graph at 2 points. Why does the vertical line cut the graph at 2 points? Because one input, see where I'm pointing? That input corresponds to two different outputs. Now, therefore, we will now define what a function is. When does a relation become a function? We talked about two types of relations. What are they? In the first type, one input gives you only one output. In the second type, one input gave us two different outputs. Well, in the first case, one input gives us one and only one output. In the second case, one input gives us two distinct outputs. Now, A relation that gives one and only one output for a given input is called a function. So, in order that a relation may qualify to be a function, what is the condition? One input should give rise to only one unique output. And that is the characteristic of a function. Now, a equal to 7.5t is a function. Why? Because one value of the input gives you only one value of the output. Whereas y squared equal to x is not a function because one input will give rise to two different outputs. And so, if I ask you, what is the test that determines if a relation is a function or not? What would you say? If I write down a relation and ask you if it is a function or not, what is the test that you will actually use to determine that? Well, first of all, if a relation contains the square of the output, look at this. If a relation contains the square of the output, it cannot be a function. If you have the square of the output, it means one input will give you two outputs. Now, the second test is if a vertical line cuts the graph of a relation in more than one point, then that relation is not a function. In fact, both these are the same if you understand what they are. So try and use these tests to make sure when you want to judge whether a given relation is a function or not. Alright, let me ask you then. Is x squared plus y squared equal to 4 a function? Well, if you look at the first test, you can see if x is the input, then y will be the output. And here you have the square of the output. And therefore you don't expect it to be a function. Alright, tell me, what does the graph of this look like? You must know, x squared plus y squared equal to 4 is actually a circle. And if you draw a vertical line, look at this. It cuts the graph at 2 points. Why? Because one input corresponds to two different outputs. Alright, I want you to do this exercise now. Determine whether the relation, this is a set of ordered pairs. So the relation is defined by a set of ordered pairs. Look at the set of ordered pairs there. 3, 3, 3, 6, 4, negative 6, 4, 6. Does this define a function? Now remember, in a set of ordered pairs, the first value is the input and the second is the output. So if you watch here, you got 3 input in 2 ordered pairs. That means the same input produces 2 different values of the output. And therefore it is not a function. So again, an input equal to 3 gives rise to 2 different outputs, 3 and 6. Therefore, it is not a function. Alright, try the next one. Another set of ordered pairs. Negative 3, 3, 3, 3, 4, negative 6, negative 4, 6. If you look at this set, tell me, does this describe a function? Well, if you notice, no input is repeated. That means each input represents a unique output. That means this is therefore a function. How about this? X plus y equal to 12. Is that a function? Well, remember, generally, we use x for input and y for output. And therefore, if you solve this equation for y, you get y equal to 12 minus x. Now, if you use an input value here, will that input give you more than one output? Well, I don't think so. That means this is a relation where one value of the input will give you only one value of the output. Therefore, that is a function. How about this? X squared plus 2y squared equal to 25. Is that a function? Well, in first look, you can say if x is the input, y will be the output. We got y squared there, therefore it cannot be a function. All right, let's solve for y. Always solve for the output to represent it in a proper function form. So 2y squared equal to 25 minus x squared. And now divide both sides by 2. You get y squared is 25 minus x squared over 2. And take the square root of both sides. What will you get? You get y equal to plus or minus, is that right? Square root 25 minus x squared over 2. That means for every x value, there are two different y values. An input of x gives to two different outputs, and therefore this is not a function. Now, how about the graph of this? How do you graph that? On the calculator, well, you know how to use the calculator for graphing. So what do you do on the calculator? Type in y1 equal to square root of, look at the way I have entered it, 25 minus x squared. y2 equal to negative square root 25 minus x squared over 2. So you are entering this as two different functions. One is the positive part and the other is the negative part. And use this window. X minimum, X maximum, Y minimum, Y maximum, and draw the graph. Look at that. It is not a circle, but it's an ellipse. And if you draw a vertical line, it will cut the graph at two different points, and therefore this relation is not a function. All right. We said a equal to 7.5t is a function because one value of t gives only one value of a. Is that right? And since the amount of dollars, the amount of money the student earns depends on the number of hours the student works, we would say a is a function of t. A depends on t. That's how functions are formed in algebra. So here a is a function of t means the amount of money the student earns depends on the number of hours the student works. So look at the way we write it. A of t equal to 7.5t. That's how you write a quantity as a function of t. A of t equal to 7.5t. A student who works for 2 hours earns $15 can be written as A of 2 equal to 7.52, that is $15. Now A of 10, what does A of 10 represent? A of 10 represents the amount of money earned by a student who works for 10 hours. That would be 7.5 times 10 is $75. Now, since a is a function of t, instead of writing a of t, it is conventional or customary to use the notation f of t. See, a of t is actually the same as f of t. So I can write f of t equal to 7.5t. In this relation, t represents the input and f of t represents the output. All right. Now, f of 12 equal to 7.5 multiplied by 12 equal to 90. Similarly, f of negative 5.2 is 7.5 times negative 5.2, that is negative 39. In other words, you have any input, there is a corresponding output for this function. Let us now look at another function. Y equal to x squared minus 5. This is a function. Why? Because one value of x, one input value, will give you only one output. And also we can say the value of y depends on the value of x. And so we have x is called the input and y is called the output. This is a function because, as we said earlier, one input gives you only one output. Now therefore, y is a function of x. And how do we write it using our normal notation? We can say f of x equal to x squared minus 5. Now, f of x is a notation used for y. If you want, you can replace f of x by y and go back and write it like this: y equal to x squared minus 5. But it is conventional in algebra to represent the output of a function by, say, f of x. You can also call it h of x or g of x, a function of x. Now this function can be evaluated now for any input value. For example, f of 2 in this case will be 2 squared minus 5, that is negative 1. How about f of negative 5? F of negative 5 will be negative 5 squared minus 5, that is 20. Look at another function. Y equal to 4x cubed minus 2x plus 2. Is this a function? Yes, it is. Because one value of x will give you only one value of y. And we can write this using the function notation. You see, because we have already used f of x, this time we're going to use h of x. H of x equal to 4x cubed minus 2x plus 2. Does it make any difference? Not really. We can, for any input, there's an output. The output here is called h of x. Now, what is h of negative 1? Replace your x by negative 1. It'll be 4 times negative 1 to the power of 3 minus 2 times negative 1 plus 2. And do that on your own. That should give you 4 times negative 1, because negative 1 to the power of 3 is negative 1, plus negative 2 times negative 1 is positive 2, plus 2. And that will be negative 4 plus 2 equal to 0. So when the input equal to negative 1, the output equal to 0. How about h of 3? What does h of 3 means? What is the output of the function when the input equal to 3? Alright, replace your x by 3. It'll be 4 times 3 cubed minus 2 times 3 plus 2. And that will be 3 cubed is 3 times 3 times 3 is 27. So that will be 4 times 27 minus 6 plus 2. And that is 108 minus 4. That is 104. Now look at this animated illustration of a function. Now this is actually a web page. I would like to acknowledge the use of some of these open web pages that are available and can be used to teach students without making any monetary reward, I suppose. So I think that should be okay. Now, let me go to that web page and show you how input and output of a function are related. Now, here you have the graph of a function which establishes a relation between the input x and the output f of x. When the input is x, the output is f of x. Remember, the length of that line is f of x. Now, if you change the input, watch when the input is changed, how the output also changes. You can actually study how the output varies for different values of the input. This is a very useful graph, and every time you interpret a graph, you must understand the relation between the input and the output. Now, here it says f of negative 0.78 equal to 1.06, which is greater than 0. When the function is greater than 0, the graph of that function will be above the x-axis. And look at what happens when the output is negative. F of negative 2.75 is negative 0.86, and that is less than 0, meaning it is negative. When the output is negative, the function graph comes below the x-axis. So this is a very useful tool to study the graph of a function. Alright, let's look at some more functions and study the relation between input and output. We have f of x equal to 2x plus 8, and we are required to evaluate f of negative 4. Well, in order to evaluate f of negative 4, replace your x by whatever input is given. So f of negative 4 will be 2 times negative 4 plus 8. And that will be 2 times negative 4 is negative 8 plus 8 is 0. How about f of x plus 1? What does that mean? It means in the original function, x is replaced by x plus 1. The input x here is replaced by x plus 1. So f of x plus 1 is 2 times x plus 1 plus 8. And now distribute that. That will be 2x plus 2 plus 8. That is 2x plus 10. Okay, how about f of negative a? What does that mean? It means in the given function, the input x is replaced by negative a. So f of negative a is 2 times negative a plus 8. That will be negative 2a plus 8. Alright, another one. If h of x, now remember, you can call a function in any of these forms. You can call it f of x, h of x, g of x are all different forms of the output of a function. So if h of x equal to x cubed minus 2x plus 3, find the value of h of negative 2, h of 3a, and h of negative a, which is not very different from what we did already. What we need to do is h of negative 2, replace your input x by negative 2. That gives you negative 2 to the power of 3 minus 2 multiplied by negative 2 plus 8. And that is, what is negative 2 to the power of 3? Negative 2 times negative 2 times negative 2 is negative 8. So that will be negative 8. Negative 2 times negative 2 is positive 4 plus 8, and that's equal to 4. How about h of 3a? It means in the original function, the input x is replaced by 3a. So what does that give you? It'll be 3a all to the power of 3. Remember that. X cubed. X is replaced by 3a. So both 3 and a are raised to the power of 3. Minus 2 times x. X is replaced by 3a plus 8. What is this? This is 3 cubed times a cube, which is 27a cubed minus 6a plus 8. And the third one, we need to find h of negative a. Replace x by negative a. That's very simple. Alright. Another one. If f of t equal to square root of 16 minus t plus 8, find the value of f of 12 and f of 16 minus 2t. What do we do? To find f of 12, replace in the function t by 12. Let's do that. So f of 12 equal to square root of 16 minus 12 plus 8. Remember that plus 8 is outside the square root. And that will be square root of 4 plus 8. And that gives you 10. F of 12 equal to 10. How about f of 16 minus 2t? What do we do? Replace this t by 16 minus 2t. So be careful when you do that. Watch this. F of 16 minus 2t is square root of 16 minus. This t is replaced by 16 minus 2t. That means you need to write that quantity inside a parenthesis because of the negative sign here. 16 minus t. T is replaced by 16 minus 2t. So 16 minus parenthesis 16 minus 2t plus 8. And now distribute that negative sign. You get, it'll be square root 16 minus 16 plus 2t plus 8. Now simplify inside the radical. 16 minus 16 will go, leaving square root 2t plus 8. Another one. If f of x equal to 2x cubed minus 5 over x squared plus 1, find the value of f of 2, f of negative 2, and f of negative a. Again, that's not difficult. F of 2, replace your x by 2. That will be 2 times 2 cubed minus 5 divided by 2 squared plus 1. Simplify that. 2 cubed is 8. 8 times 2 is 16. So that will be 16 minus 5. And on the denominator, 2 squared is 4 plus 1 is 5. That gives you 11 over 5 as f of 2. How about f of negative 2? F of negative 2 is, replace your x by negative 2. It will be 2 times negative 2 to the power of 3 minus 5 over negative 2 to the power of 2 plus 1. What is negative 2 to the power of 3? That is negative 8. So it is 2 times negative 8. That will be negative 16 minus 5 over negative 2 squared is positive 4 plus 1 is 5. I hope you're following the simplification. That should be a very simple process. Negative 2 to the power of 3 is negative 8. Negative 8 times 2 is negative 16 minus 5. And what does that give you? Negative 21 over 5. Now, how about f of negative a? What all you need to do is replace your x by negative a, and that is a much simpler process. we will now discuss the concept of domain and range of functions. What is the meaning of domain? Domain is actually a field of influence. What is the meaning of domain of a function? Well, you know that a function has an input and an output. For example, consider f of t equal to 7.5t. Now, each value of t will give you an output value for the function. In other words, there are no values of t that will not give you an output for this function. Any value that you can think of as an input will give you an output. In other words, you can actually use all possible real numbers as its input. The field of influence is infinite. So we say any number from negative infinity to positive infinity can be used as an input there. Each of those inputs will give you an output. And therefore, we say the domain of this function contains all real numbers. And the way we say it is, the set of all real numbers are possible inputs of this. And so the domain of the function contains all real numbers from negative infinity to positive infinity. And that's the way we describe the domain. The input of this function can be any real number from negative infinity to positive infinity. And how do we write it? Look at the way we write it. Domain is the set of, this is the way to read it, the set of all real numbers from negative infinity to positive infinity. But when you say the set of all real numbers, it includes all numbers from negative infinity to positive infinity. So what is the domain of this function? The domain of this function is the set of all real numbers from negative infinity to positive infinity. It means there is no input that is excluded. That's the meaning in there. Now, how about the range of a function? The range of a function. What is the reach of the function? In other words, when you put in these input, what kind of outputs you get? Well, the function we just talked about can have any output depending on the input. So, the set of all possible outputs of a function is called the range of the function. What do you think is the range of the function we were considering? A of t or f of t equal to 7.5t. Well, no matter what the input is, there is an output. And that output can be any real number. It can be any number on the number line. It can be from negative infinity to positive infinity. In other words, there is no output that is impossible. That is what is meant by this. There is no output that is forbidden. All outputs are possible for such a function. So what is the domain? It contains all real numbers from negative infinity to positive infinity, and this is the way we write it. So, for a function such as this, no input is forbidden and no output is forbidden. All real numbers are possible inputs and all real numbers are possible outputs. That means if you draw the graph of this function, that graph will be a continuous graph. There will be no break in the graph anywhere. Now, a graph of y equal to 7.5x can be used to study the domain and range. Now, how do we draw the graph of that? It's very simple. Go to y equal to on your TI-84 or TI-83 calculator. We will be using a TI-84 or TI-83 calculator. and put in 7.5x and use this window. X minimum -3, x maximum 3, y minimum -20, y maximum 20, and press graph over here. Press graph, and you see the graph. What it tells you is that there is no input that is prohibited, and there is no output that is prohibited. The graph is a continuous line. That means the domain and the range both contain all real numbers from -infinity to +infinity. All right. Now consider the function y equal to 1 over x. All right, now tell me, is it possible to use any input in there? How about if I have an input of x equal to 0? What is the value of 1 over 0? Well, a number divided by 0 is undefined. We don't know what it is. It is so big, because you see, 1 over 0.5 is 2, 1 over 0.1 is 10, 1 over 0.01 is 100, 1 over 0.001 is 1,000. That means as the denominator gets closer and closer to 0, the output increases without bounds. So when the denominator is actually 0, we don't know what the value is. That means x equal to 0 is not a possible input. That means this function cannot have an input x equal to 0. So what is the value of 1 over x when x equal to 0? It has no real value. 0 on the denominator of a rational expression makes it undefined. This means that 0 is not a possible input for this function. 0 cannot be an input for this function. What that means is 0 is excluded from the domain of this function. All other numbers are possible. You can put any x value there except 0, you will get an output. But x equal to 0 cannot be an input. Now, how do we write that? We write it like this. The domain consists of all numbers from -infinity to 0 and 0 to infinity. But 0 is not included. That's how we use the parenthesis. You know that if 0 is included, we will use a square bracket. So this parenthesis means 0 is excluded. So -infinity to 0 union 0 to infinity means the domain contains all real numbers from -infinity to 0, 0 not included, and from 0 to +infinity, 0 not included. 0 is excluded from the domain. All right. So we know that the domain of this function does not contain 0. All right. What is the range of this function? In other words, what are the possible outputs? Well, you can get all kinds of output, but using a particular value of x there, can you produce an output of 0? Can 1 over a number ever give you an output 0? Think about it. If you say yes, give me that number which, when placed here, will give you the output equal to 0. Well, actually there is no such number. No matter what the output value of x is, no matter what the input value of x is, the output cannot be 0. In other words, we will not get an output 0 here. That means 1 over x can never be 0. So 0 is excluded from the range as well. The range does not contain 0. All real numbers except 0 are in the range of the function. How do we write it? Is it different from the domain description? No, it's the same. So the range also contains all real numbers from negative infinity to positive infinity except 0. 0 is excluded. So that's the way we write that range. Okay, let's look at the graph of 1 over x. Well, you should be, when you listen to this lecture, keep the calculator with you. Graph, this is how you do it. Press y equal to and type in 1 over x. And then go to window and type in x minimum -1, x maximum 1, y minimum -20, y maximum 20, and press graph. Look at the graph you get. What does this graph tell you? It tells you that as the input gets closer and closer to 0, the output increases, and as the input gets very close to 0, the output is very, very low. And at x equal to 0, you get no output. Similarly, as we get closer to x on the negative side, x equal to -0.0001 is, say, -10,000. So there is no input x equal to 0, and there is no output of y equal to 0. That graph is a clear indication that 0 is excluded from the domain and the range. Okay, let's look at another function, y equal to x plus 2. Tell me, is there any input, any x value that is excluded in there? How do you know? You see, you know that in a rational expression, the denominator cannot be 0. That means any value of x that make the denominator 0 cannot be an input. Now, what is the value of x that will make x plus 2 equal to 0? If x plus 2 has to be equal to 0, then x equal to -2. What it means is, when the input x equal to -2, the denominator becomes 0, and the output is 1 over 0, and 1 over 0 has no meaning, and therefore it cannot be. That means x equal to -2 cannot be an input. It is not in the domain. So what's the domain then? The domain consists of all real numbers except -2. Look at the way right again. Negative infinity to -2, union -2 to infinity. All real numbers excluding -2 is in the domain. How about the range of this function? How about the range? The same argument we used last time goes for the description of the range. No input value here will give you an output 0. Can 1 over a number produce an output equal to 0? No. So there cannot be an output 0, means the range cannot contain 0. So how do you write the range then? The range is all real numbers except 0. Alright, let's draw the graph of this function and see how that looks. Alright, try this on your own. Press y equal to. Alright, press y equal to and type in. Look at the way I typed it in. 1 over parenthesis x plus 2. and type in this window, x minimum -3, x maximum -1, y minimum -20, and y maximum 20, and then press graph. There you go. Now this is x equal to -2, because we x minimum -3 and x maximum -1. So this is -3, -2, -1. So this is -2. Now that means when x equal to -2, you get no output. There's a break in the graph. What does that mean? X equal to -2 is not in the domain. When a certain x value is not in the domain, you get a break in the graph there. The graph is not continuous there. There you go. This is x equal to -2, and there is a break in the graph there. No input is available at x equal to -2. This means that x equal to -2 is not in the domain of that function. Again, if you look at the output, you see the output goes closer and closer to 0, but it never reaches 0. There cannot be an output of 0. So 0 is not in the range of the function. All right, let's do another one. Find the domain and range of the function f of x equal to square root of x plus 3. How do you determine the domain of a function like this? What is the argument we use? What are the possible inputs in here? Can we use any value for x in there? Well, we know one thing, that square root of a negative number is undefined. That means x plus 3 cannot be negative. How do you say that in a proper mathematical statement? X plus 3 cannot be negative. If it cannot be negative, it has to be greater than 0. So x plus 3 has to be greater than or equal to 0. You see, x plus 3 can be 0, or it has to be something greater than 0. It has to be a positive value. That means if x plus 3 has to be greater than or equal to 0, x has to be greater than or equal to -3. It means no value of x less than -3 can be an input. If you put x equal to -4 here, -4 plus 3 is -1. Square root of -1 is undefined. So -4 is not in the domain. You try any number less than -3, it will not give you an output. So the domain of the function contains only x values that are greater than or equal to -3. Now, how do we write it? Now, look at the notation. Square bracket -3 to infinity, which means all real numbers from -3 to positive infinity, including -3, are in the domain of this function. Now, let's graph this function and see how it looks. All right, press y equal to and enter the function like this: square root parenthesis x plus 3, and use a window like this: y minimum -5, x minimum -5, x maximum 5, y minimum -2, y maximum 5, and press graph, and look at this graph. The graph tells you that there is no input to the left of x equal to -3. This is x equal to -3. And you get output only for numbers that are -3 or greater. There's nothing, no part of the graph appears to the left of x equal to -3. That means there is no domain values there. All right, tell me, look at the graph and tell me what is the range of this function. In other words, what are the possible output values of the function? If you notice, the graph only exists above the x-axis. There is no part of the graph below the x-axis. Remember, in the beginning I said, if the graph is above the x-axis, it represents positive outputs. If the graph is below the x-axis, it represents negative output. Since we have no part of the graph below the x-axis, it means there are no outputs that are negative. What is the minimum output you can have here? The minimum output is 0. And you can have any output greater than 0, but you cannot have an output less than 0. So the range of the function will be 0 to infinity. Alright, let's do another one of the same type. Find the domain of the function. F of t equal to square root of 24 minus 8t. Now, what is the restriction here? You need to look for restrictions if there are any in the function. Now, here the restriction is we have a square root. And you know that square root of a negative number is undefined. That means the value of 24 minus 8t has to be greater than or equal to 0. So, first thing we do is, we say the quantity inside the square root cannot be negative. It has to be greater than or equal to 0. There you are. And now solve this inequality. You know how to do that. That will be negative 8t is greater than or equal to negative 24. Move that positive 24 to the right, become negative 24. And now divide both sides by negative 8. I hope you remember your special rule there. When you divide an inequality by a negative number, the sign of the inequality must reverse. That means dividing by negative 8 will give you t is less than or equal to 3. How do you produce that? Divide both sides of the inequality by negative 8. And when you divide by negative 8, the inequality sign reverses. So the domain consists of values of t that are less than or equal to 3. You cannot have an input that is greater than 3 in there. How do you write it? You can have input all the way from negative infinity up to positive 3, 3 included, square bracket. Negative infinity to 3, square bracket. Alright, can you draw the graph of this? Alright, let's press y equal to and put in your function there. Remember, t has to be replaced by x. So on the calculator, the variable is x. So square root, parenthesis, 24 minus 8x. And window, let's use x minimum negative 5, x maximum 5, y minimum negative 2, y maximum positive 15, and press graph, and look at that graph. What does that tell you? It tells you that there are no domain values greater than 3. 3 is the lowest value of the domain that is allowed. Any domain value less than 3 is allowed, but including 3, but not greater than 3. So the domain is negative infinity to 3, 3 included. And how about the range? The range only exists above the x-axis. That means only positive values. The range is 0 to infinity. Okay, so looking at a graph is a very good way of studying the domain and range of functions. Alright, let's now practice looking at the graphs of some functions to determine the domain and range of such functions. F of x equal to square root x squared minus 5x minus 24. Can you draw the graph of this on your own? Alright? Enter your function, press y equal to, and put y1 equal to square root of, parenthesis, x squared minus 5x minus 24. And the window, use this window. X minimum negative 10, x maximum 15, y minimum negative 2, y maximum 15. You can actually obtain this by trial and error. If you don't like the look of the graph, you can go and change the window. Alright, press the graph and see how that graph looks. Isn't that a beautiful graph? What does this tell you? Well, you look at this. There are two segments for this graph. It means for x less than negative 3, there are outputs, and x greater than, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Greater than 8, there are outputs, but no outputs for x values from negative 3 to 8. That means x equal to negative 3 to 8 is not in the domain of the function. And how about the range? The output exists only above the x-axis. That means the range contains only numbers from 0 to infinity. That's right. So this is x equal to negative 3. That is x equal to 8. There are no output values between x equal to negative 3 and x equal to 8. That means the domain does not include the numbers between negative 3 and 8. But do they include negative 3 and 8? Yes, they do. So, look at the way we write the domain. The domain contains all real numbers from negative infinity to negative 3 included, union, 8 to infinity, 8 included. But no numbers between negative 3 and 8 are in the domain. Alright? Okay, and the range is 0 to infinity, 0 included. An output of 0 is possible, and anything greater than 0, but there is no output below the x-axis. Alright, let's look at this graph. I have given you the graph of a function. Now, what is the domain and range of this function? Can you look at the graph and tell me what is the domain of this function? Now, how do you look at the graph? And now look at the output. Now, the graph values are the output, is that right? These are the output values. Now, what does this output do? It goes all the way to negative infinity. And this output comes all the way from positive infinity and goes to negative infinity. What that means is, if you look here, x equal to negative 1 does not give you an output. So x equal to negative 1, there is a break in the graph. So x equal to negative 1 is not in the domain of the graph. Is there another break in the graph? Yes, x equal to 2, there is a break in the graph. That means there are two input values that are excluded in the domain. There are two breaks in the graph. X equal to negative 1 is not in the domain. X equal to 2 is not in the domain. So how do you write that? You would say negative infinity to negative 1, bracket, union, negative 1 to 2, is that bracket or parenthesis? Let's come again. Negative infinity to negative 1, is that bracket or parenthesis? Parenthesis, because negative 1 is not included. Then union, negative 1 to 2, any input from negative 1 to 2 is okay, except negative 1 and 2. Then union 2 to infinity. That is the domain. All right, how about the range of this graph? If you look at the middle part, there are outputs continuous. There's no break in there. That means there are no output values that are excluded. All output values are possible. So what is the range? The range is all the way from negative infinity to positive infinity. All right? So the domain is negative infinity to negative 1. Look at the parenthesis there. Union. Negative 1 to 2. Parenthesis. Union 2 to infinity. It means there are two x values that are excluded. That is, negative 1 is not included. 2 is not included in the domain. And the range is negative infinity to positive infinity. We will now discuss the meaning of rate of change of a function. What does rate of change of a function means? When input changes, the output also changes. So the rate of change means the change in the output divided by the change in the input. That is what we call rate of change. Now, let me explain that using our familiar function, f of t equal to 7.5t. What does this function tell you? When a student works for t hours, the student takes home an amount of money given by f of t. When time t in hours is the input, the output is f of t. Now, f of 5, when a student works for 5 hours, he takes home $37.5. F of 8, if the student works for 8 hours, the student takes home 7.5 times 8, that is $60. Now that means the input changed from 5 hours to 8 hours, and the output changed from $37.5 to $60. All right, what does f of 8 minus f of 5 represent? Tell me, can you give me a sentence explaining what does this mean? F of 8 minus f of 5. F of 8 represents the amount of money the student gets when he works for 8 hours. F of 5 represents the amount of money he earns when he works for 5 hours. So f of 8 minus f of 5 represent the extra amount of money when the student works for 3 more hours, isn't it? After working for 5 hours, the student works for 3 more hours to complete 8 hours. So f of 8 minus f of 5 represents that extra amount of money the student earns when he works for 3 more hours. The change in the output, when the input changes by how much? The input changed by 8 minus 5. So, what does this represent? F of 8 minus f of 5 divided by 8 minus 5. F of 8 minus f of 5 represents the change in the amount of money the student earns when he works for 3 more hours. The change in the input is 8 minus 5. So what this represents is the change in the output divided by the change in the input. And this quantity is called the average rate of change of that function. So, average rate of change of a function is a measure of the change in the value of the function divided by the change in the input that causes that change in the output. Now, in this case, f of 8 minus f of 5 is 60 minus 37.5, there you are, divided by 8 minus 5, and what does it give you? It is 7.5. And what is 7.5? 7.5, isn't that the rate of pay of the student? Yes. So what does this represent? The change in the function value divided by the change in the input value is a measure of the average rate of change. And the average rate of change here is 7.5. It means every time the student works for 1 more hour, the student takes home $7.5 more. That's the meaning of the average rate of change. And if you draw the graph of this function, what would be the slope of that graph? It'll be 7.5. So the slope of a graph actually represents an average rate of change of that function. All right. Well, I asked you here, what is another name for rate of change? I just answered it. It is actually a measure of the slope of the graph. All right. We just said f of 8 minus f of 5. I can write it like this. F of 8 is f of 5 plus 3 minus f of 5 over 8 minus 5 is 3. Now this is a measure of the average rate of change of f of x when the input changes from x equal to 5 to x equal to 8. I hope that is now clear. This is a measure of the average rate of change. This is the measure of the change in the function value. This is a measure of the change in the input. So the f of 5 plus 3 minus f of 5 divided by 3 is a measure of the average rate of change when the input changes by an amount equal to 3. Now, that's the reason why I wrote it like this. 5 plus 3. That plus 3 represents the amount of change in the input. What does f of x plus h minus f of x over h then represent? What is the meaning of this quantity? Well, this is the change in the output when the input changes by a quantity h. So, change in the output divided by change in the input is a measure of the average rate of change when the input changes by a quantity called h. That's right. X changes from x equal to x equal to x plus h. The change in the x value is h. And that change in the x value caused a change in the output equal to this. Very important concept, especially when you go into calculus. All right, I want you to now use a function and calculate this quantity. What is that? Calculate f of 3 plus 2 minus f of 3 over 2. In other words, calculate the average rate of change of this function when x changes from 3 to 5. Is that right? So, first we find f of 3 plus 2. In other words, f of 5. Replace your x by 5. That will be 5 squared minus 5 times 5 plus 8. That gives you 8. So f of 3 plus 2 is 8. And f of 3 is 3 squared minus 5 times 3 plus 8. Replace your x by 3. That gives you 2. So what is the change in the function value? The f of 3 plus 2 is 8. F of 3 is 2. Therefore, what is f of 3 plus 2 minus f of 3? That will be 8 minus 2 on the numerator. So that will be 8 minus 2 over 2, and that's equal to 3. So what does the 3 represent? The 3 is the average rate of change of this function when the input changes from x equal to 3 to x equal to 5. That's the meaning of that. This means every time the input changes by 1 unit, the output will change by 3 units. That's the meaning of that. How about this? Evaluate f of x plus h minus f of x over h for this function? Well, first of all, we will find f of x plus h. How? By replacing our x here by x plus h. Let's do that. F of x plus h is x squared becomes x plus h squared minus 5x becomes 5 times x plus h plus 8. Let's simplify that. Can you expand x plus h squared? It will be x squared plus 2xh plus h squared. So that will be x squared plus 2xh plus h squared, and then minus 5x minus 5h plus h. This is the quantity f of x plus 8. And now f of x we know is x squared minus 5x plus 3. And therefore what is f of x plus h minus f of x? It will be 8. It will be this whole quantity minus this. How do I write that? I'm going to copy and paste that here. That quantity minus this quantity. And now I need to expand this by distributing the negative sign. So the only change there is that will be minus x squared plus 5x minus 8. And you can see I have used green colors. X squared minus x squared will go, minus 5x plus 5x will go, plus 8 minus 8 will go, leaving us simply 2xh plus h squared minus 5h there. Now I can factor out an h there. That will be h times 2x minus 5 plus h. That is this quantity, the change in the function value. And now we have the change in the function value is this. We need to now divide it by h. So we take this quantity and divide it by h. And h will cancel, leaving us with the final result 2x minus 5 plus h. And actually, this is the average rate of change of this function when the input changes by a small quantity called h. And you must be familiar with doing these kind of problems because it is very important in calculus, which will be your next course, I think. Now I want you to take a few minutes and work out the same concept, this quantity, the rate of change of the function for this function 1 over 3x. And let me know how it has been going.